Okay, what I was saying, so we have this kind of object, ds square, let me ds prime square, that's actually proportional to ds square. Let me write a constant of proportional to as f. Okay, so much. Let's write f. We will put the argument of the f on what kind of parameters it should depend. Everybody got it what I am saying? So now if you say, let's say ds is 0 in one frame of reference, so ds prime is 0, is it? Both ds and ds prime, they are of the quadratic form, is it? So so much order of magnitude of ds and ds prime are same, is it? So that's why they should be proportional to each other. Okay. Now the point is on what factors this proportionality constant depends. Okay. And normal, I mean, conclusion we can draw is that f should most probably depend on the relative velocity between the two frames, is it? Tisha, do you agree with that? It should depend. Okay, what is the relation between two frames of reference? It's actually the relative velocity, at what velocity or at what inclination two frames are, is it? When I observe one ds, okay, when I calculate one ds in one frame of reference, ds prime when I try to calculate, okay, so from ds, if I try to calculate ds prime from ds, so I should take into account what is the relative velocity between the two frames, is it? And normal, I mean as an argument I am saying, okay, and I can think, okay, what is the inclination angle between the two frames, is it? So these are the things on which it can depend, is it? Clear? Let's think it depends upon the, let's assume it depends on the relative velocity, this vector v. Okay? Just try to understand first. Okay. Now there is actually, okay, two principles are in physics. One is known as the homogeneity of space and time, and another principle is the isotropy of space, is it? Okay, what is homogeneity of space? Let's say. Have you heard this kind of point?
Result of any experiment is invariant if you move in any direction.
Okay, so in any direction or in
straight direction.
Direction. Okay, so that is
homogeneity
of space. Okay, and in time? Time is the same thing. Okay, same kind of objective. And isotropy means if you move in any direction, so it is same. Okay, so much. Okay, so let's take first thing. Homogeneity of space and time. Homogeneity of space. I am weak at spelling. So I am saying my space is homogeneous. Okay. So that means if I move from one point to the another point, I cannot distinguish between the motions. Is it? So it will be the same thing. Every instant of time, at every instant of time, my space is same. If I translate, let's say if I translate it from one point to the another point, I encounter the same kind of space. All the space points are same, is it? Similarly, at time points, if I am moving, let's say in space and time, all space and time points are what? Same, identical. Okay? So I cannot distinguish between the any space-time points. That is what we call the homogeneity of space and time. Now, if that happens, now what conclusion we can draw for this f of v from here? Now, okay, I am saying I am having a function that depends upon, let's say, a velocity vector. That means on the angle and everything, is it? Try to understand it. Now, if I am saying my space time, let's forget about time. My space is homogeneous, is it? I cannot distinguish between any points. Now, when I am saying my any given function here, it is f of v, it depends on velocity vector, is it? So this velocity vector will be different at different points because it's a vector, is it? So it will depend on, so sometimes it may depend on the angle between two frames, or sometimes it may depend on any weird object, is it? So that means at every point, at every special point, it will be different thing, is it? But we can attach, since we are doing with the inertial frames, I am saying all inertial frames are equivalent, is it? When I am saying my space is homogeneous, okay, I cannot distinguish between any kind of frames of reference, is it? समझ आओ? But if I am saying my f of v depends on v, this vector v distinguish between the different points. Because it is a vector, it will at every instant of time I'll be having a different vector, or at every space time point. Let's say you okay, so this is a crude example, I mean crude imagination. So let's take this point, all these points. You can attach a frame of reference to every point. Okay, they are all equivalent. Space is homogeneous. Now, if I am saying you are having a vector v here, so f of v here, let's say f of v here. So let's assume these 2 points. So if this depended on, okay, if this function depends on this v, okay, so that means this very point I can distinguish from this. So that means I can distinguish all these kinds of points. What is the basic assumption? Space is homogeneous. I cannot distinguish between all these kinds of points. So this is a contradiction. Okay, what is the physical thing, or what kind of unphysical thing it may yield? Let's assume it depends on this thing, and still our space is homogeneous. But what is the unphysical it may result? Since I am saying there is no privileged frame of reference by first postulate of relativity, is it? So when it depends on this thing, it violates the homogeneity of space here, is it? So that means you can be having one point more privileged than another points, is it? So in other words, I can be having the privileged frames of references, which contradicts the first postulate of the relativity. All inertial frames are equivalent, is it? So this may result in an inequivalent frames of reference. Got it? Now tell me what quantity I can figure out on which then this f must depend. Okay, what is a quantity which can be uniform throughout? It's simply the magnitude of the velocity. Just that is a number. It may not depend on the vector v, it may depend on what? Just the magnitude of this very vector. You got my point? Similarly, if I am taking, let's say, the isotropy point, the same thing that may also result in the same kind of conclusion. So isotropy of space means in any direction the space is same, is it? All points will be equivalent. But if my f depends on this v, so all the points will not be equivalent. Okay, so it may still yield this concept of privileged frames, which is contradiction to the first postulate. Okay, so that means this f must depend on what? The magnitude of velocity. So this I can write like this, simply f of v ds. Okay, so this is the magnitude of the velocity. Or the absolute value of the relative velocity. Clear? We need to now figure out what this f of v is. Okay? So much, Shaman? Okay, now let's try to figure them out. Okay. So let's consider, okay, let's try to figure out this f of v. Any question? Okay, so let's consider a frame. You are having a frame K, and then you are having a frame K prime. Let's say this K prime moves with relative velocity v, is it? Now by that very definition, okay, ds prime square is equal to f of v ds square. Okay, just by that way, I'm just rewriting that thing. So you are having K prime moving. Okay, let me write K prime moving with respect to K with velocity, with relative velocity v. Okay. Now let's assume another frame of reference. So I will assume another frame of reference. So you are having K here. Okay. Or let's say I am assuming another frame of reference which moves with respect to this K prime at a minus velocity. Okay, so this is a K double prime frame. It moves with respect to which frame? K prime with a velocity minus v. Okay, so that means I'm having, okay, so you take this K prime frame, so it moves with velocity v. Now you are having another frame, it moves with K in the backward direction, simply. So now let's write, so you are having K double prime with respect to what? K prime at minus v. Tisha? So what it will be? By this definition, by that very definition, ds double prime square, that's equal to f of v, simply f of v, because it depends on the magnitude, is it? Oh, so much one. So ds prime square. Tisha? Clear? So call it a second. Okay. Now let's write this ds prime square. So it will be simply f of v. Okay, from first I can write this ds prime. Okay, so it is f of v ds square. Okay, can anybody tell me what this k double prime is? Huh? What is k double prime is? Oh, what is k double prime? It moves with respect to k prime at a velocity minus v, is it? So where it will go? As a k, is it? So k double prime is same as what? K. Samashaman? So in other words, I can say what this ds this will be. ds prime double prime will be same as ds, is it? So since k double prime is same as k, is it? So which implies therefore, so I'll be having simply ds square is equal to f square v and ds square. So what it gives me? So which implies f of v is 1 plus 1. Okay, f of v is equal to minus 1 is absurd. Okay, we can verify this conclusion another way. Okay, so much on. So what it gives me? Now f of v is 1, is it? So ds prime square is same as what? So what are they? They are the intervals, is it? Or the length of the interval. So it's the same thing when you go from one frame to the another frame, it turns out to be the same, is it? So what we call that? It's an absolute quantity. So the equation of this ds square is equal to that gives me the concept, or rather provides us the second postulate of the relativity. It gives the mathematical form of the second postulate. Constancy of the speed of light. Okay, let's prove this kind of, since we have said this f of v equal to minus 1 is absurd. Okay, let's arrive at this f of v from the another argument. Okay, so that it can be clear. Okay, let's take k frame. Okay, and with respect to k, I am having k1 frame moving with velocity. Okay, relative velocity is v1. Okay, so that means I am having this k frame, and with respect to this k frame, I am having this k1. So much on with velocity v1. Okay, so now let's write this ds. So I am having this. What is it? ds1 square. That will be same as actually f of v ds square. Tisha? Tisha? Any question? Or I can write like this thing: ds square and ds1 square. It is one and the same thing. Okay, because they are proportional to each other, I can interchange the things. So, samajh aawa? Clear? Okay. Now let's take the another case when I am having, let's say the same k frame, you are having another frame k2 that moves with velocity what? v2. So what I can write? So let's write. So it will be depend on the magnitude of the velocity v1. Sorry, it is magnitude of velocity v1 between the two frames, is it? So ds square will be same as what? F of v2 ds square 2. Tisha? Clear? So samajh aawa? Okay, so what it yields me? Since you are having k1 moving with respect to k, k2 moving with respect to k, is it? So samajh aawa? Since ds square is same here, so I can equate the two, which gives me what? F of v1 ds1 square is equal to f of v2 ds square 2. Okay? Clear? Okay, now there is one more piece of information in our problem. So that is k1 and k2. They are also moving related to each other. If k1 is moving with respect to k and k2 is moving with respect to k, it means k1 and k2 are also moving related to each other. Okay? Okay. So we are having now k1, okay, so then you are having k2. So we don't know what is the orientation between the two, is it? So samajh aawa? Now let's write the, so that will be simply what? v12 will be the velocity between 1 and 2. कुछ समझ आवा? Okay, so let's write them. So I'll be having ds1 square as f of v12 ds square 2. समझ आवा? Clear? Where v1 is the magnitude of the velocity between what? k1 and k2. But even if I take the magnitude of this v12, still it will contain an angle. Okay. Now, if you have, let's say, if you are having vectors a and b, okay, so they subtend an angle alpha. So you try to figure out the third. So you are having vector a, vector b, and you try to figure out vector. What is the magnitude of c? So it is root of a square plus b square minus twice, okay, ab cos of angle. So it still depends upon the angle, is it? Although it's the magnitude, it depends on what? An angle. Samasha? Okay, now let's do, pause a second. Let's use ds1 square in that very equation. Use this ds1 there. So I'll be having, so from here I am having this f of v1. So it will be f of v12 ds square 2 is equal to f of v2 ds square 2. So what it gives me? So it gives me simply f of v12, that is same as what? F of v2 by f of v. Tisha? Is it? Clear? Now tell me, the left hand side of this very equation depends on angle, is it? But the right hand side does not depend on angle. So this is a number, this is also a number, is it? This depends upon the magnitude of this very velocity, and this also depends on the magnitude of the, this also depends on the magnitude of the velocity, but it contains what? An angle between the two vectors, is it? Is it clear? So when this equation can be consistent, I mean when this equation is true. No, tell me, just think. What I am saying, I am having an equation on the left hand side, there is an angle, and on the right hand side there is no angle. There is no dependence on the angle. So when this equation can be true? Forget about, there is nothing. It can be arbitrary. We are doing it in the arbitrary sense. We started from the arbitrary way. So when they are the constants, that means when they are the constant, there will be no angle dependence. What I mean to say, this f should be constant itself, is it? Utisha? It should be a constant function, let's assume. When it is a constant function, it will be constant on the right hand side and constant on left hand side, is it? So in that sense, it will not depend on any kind of angle. Okay, so for this equation to be consistent or having a solution, then f should be a constant, is it? So, but this constant should be same whether you move from one frame to the another frame, is it? So much you go from here, here. So that means f of v1 should be same as f of v2, is it? It should be same as what? F of v12, is it? Because I am saying it is a constant. Now look at this. This ratio will be what? So constant by constant is what? 1, is it? So they are the same things, is it? So then what is f of v12? It's a constant that's equal to 1. So then this equation can be having a solution only when f is a constant and that constant is equal to 1. Everybody got it what I was saying here? Huh? Everybody followed it? Okay? So for this equation to be consistent, f must be constant, and that constant, and that should be equal to 1. Okay, so now you are having what we have arrived at, means we are having this quantity which we call as an absolute quantity. Now frame to the another frame, it is the same thing. So ds is same as ds prime. Okay, this dt and dt prime, they can change, but this object is different. I mean same. Okay, so this okay, so that you write. So this is the interval between two events. Okay, that's right. Two events is the same. All inertial. That's transformation. Okay, so this is the result of what we have arrived at. So this invariance is the mathematical constancy. Okay, so this very statement means, so you are having ds term, so it means c square, so it is in one frame, so it is same as where c square dt prime square minus dx prime square minus dy prime square. So it is this very statement. Okay, so now what we have done till now, we have identified a four-dimensional space and time. Okay, time serves as a coordinate of an event, is it? Okay, now how we can, let's say if I have a trajectory, a particle moves, how I can assign the time for that? The way we think of the time evolution, time evolution of an object. Okay, how I can write that kind of time evolution? Now this time I cannot take as the the parameter or the evolution time. So much on what kind of time I should take now? So let's try to figure out that. Okay, let's say if you are moving from one point to the another point, okay, let's say this is a kind of trajectory from one point to the another point. So at every point of this very trajectory, okay, so let's say a particle moves from point A to point B, so you can attach a frame of reference to every point, is it? Can you attach? You can attach. So when you attach a frame of reference is always, frame of reference consists two things always: a meter rod to measure the length and a clock to measure the time. Okay, so that means at every point you can assign a clock. Okay, so and this clock is moving from point A to point B. Now let's try to measure the time on a moving clock. Samajh? Okay, because I need to, okay, you can take, let's say at t equal to 0, at some initial time where the particles at rest, okay, all the frames you can, the frames of reference what you are considering, you can first match their origins and synchronize the length. At least you synchronize the time. Okay, you just synchronize all the clocks and allow them to move then, is it? So that means I can do the synchronization at this very point of all the clocks, and now these clocks are moving with respect to this very point. Okay, and I will try to figure, since the observer is, let's assume the observer is at this very point, and this observer will observe the time on these clocks. Okay, let's say you are having a clock that's moving along this very trajectory, so this observer is trying to observe this very time. So much even the time that we can observe on this very clock, okay, or the time, sorry, I should put it this way, the time this clock shows, the moving clock shows, okay, this moving clock is actually at rest in its own frame of reference, is it? So that time we call it the proper time of the system, or the proper time of the frame of reference. Samajh aawa? Or the proper time shown by the clock, shown by the moving clock. So samajh aawa? So there are two times arising here, the time what we measure and the time which a clock shows in its own frame of reference. Okay, and this proper time is actually an absolute quantity. Okay, it will serve as a parameter instead of the time coordinate. Okay, so samajh aawa? Okay, now let's try to figure out this proper time. Everybody got the point? What I am trying to say? Huh? Okay. So let's take this concept of the proper time. Okay, we'll take two clocks. Okay. Let's take two frames of reference. So your frame K and another frame K prime is moving with respect to this K with a velocity V. Okay, so this is K prime frame. Okay, let's attach a clock to this very frame. And you are having a clock here. You measure. Okay, you will first, what you will do, you synchronize the two clocks, is it? So you take the origin here and origin here, match the origins such that it will appear as the one coordinate system, is it? Samashivan? So then you synchronize the timers on both the clocks and then allow one clock to move. Samashivan? So since this is a moving clock, but this clock is at rest in its own frame of reference, the time that will be shown by this very clock is a proper time. Okay? Now let's look from this very frame of reference, is it? Okay. So what is the special? Okay, let's say your hand coordinates. It started. Your hand coordinates x1, y1, z1. Okay, special coordinates, and x2, y2, z2. Okay. Samajhama? So you started. Okay. So the clock. You observe at 2 points. Okay, 2 special points. Let's say at this very point and another point here. Okay, you observe it. So the special coordinates in this very frame of reference, they are x1, y1, z1 and x2, y2, z2. How much distance it has covered with respect to k? So it will be simply the difference squares of the difference, is it? So I will write it like this thing. Okay. So I am having the special distance dl. So that's observed where? Dx square plus dy square plus dz square. Which distance it is? It's a distance covered by this moving clock with respect to what? Or that is observed in K frame simply. So, in K frame, this is the amount of distance which is covered by this moving clock. So, you got it? Okay. So now let's try to calculate dt prime. Okay. So let's calculate the time prime. Okay, so from this very invariance, okay, from this very relation, let me take from the invariance of intervals. Okay, now in this frame of reference, what are these 2 points? Since what we are trying to measure, it's a very confusing thing. You should understand it properly. What we are trying to measure? We are trying to measure the time, is it? But since the clock has moved from one point to the another point, so we will be just assuming, we will be just measuring the time from between these 2 points, okay? But this clock is at rest with respect to special coordinates, is it? In its own frame of reference. That means what are same? x1 prime is same as x2 prime, y1 prime is same as y2 prime, and z1 prime is same as z2 prime, okay? But it is not same here, because with respect to this frame of reference, I am observing the clock has moved a certain distance. But it is in its own frame, it's at rest. Okay. Now let's look at this very thing. So you are having c square. Let me write it this way. Let me write t1 minus t2 square minus x2 minus x1 square minus y1 minus y2 square minus z1 minus z2 square. That is same as what? C square. Okay, t1 prime minus t2 prime square minus x2 prime minus, so it is t2. So it is the same thing, but I will, okay, x1 prime square minus y2 minus y1 prime square minus z2 prime minus z1 prime square. Now like, so it's like this. Although it is in the square, it will be the same thing, but you should, okay. Samajh aa? Okay, now since it in its own frame of reference, what this object is? This is 0. Tisha? So x1 is same as, okay, x prime is same as x prime, okay, x1 prime, so this object is 0 in its own frame. X equal to 0. Okay. So okay, so I can write this as c square delta t square minus delta x square minus delta y square minus delta z square. That's same as delta t prime square. Clear? You sure? So if they are infinitesimally close to each other, now what that will yield me? So I'll be having c square dt prime square, that's equal to c square dt square 1 minus what this will be? Simply dl square divided by dt square. Because dl I have defined this object, is it? When they are infinitesimally close to each other, it will be like this object. Clear? And there will be c square as well. Clear? Clear? Okay, so what this is? So it will be simply dt prime is equal to dt. Okay, c and c goes, so it is root of 1 minus v square by c square. You sure? Clear?
Yes, sir.
So now tell me, what is this time? It is the time shown by the moving clock, is it? Okay? So this is the time what we measure where? Huh? Oh, where? It's in the K frame. dt is the time what we are measuring. So what it says?
Time is not the same.
Obviously time is not same. It is time dilation. What does that mean? So the moving clocks move slower, is it? So they are going slowly. So the time that we observe in a moving clock, that slows down. Clear? So that is the concept of the time dilation. So you have heard about the famous paradox. It gives what is that paradox? Twin paradox. Have you heard about it? Huh? Okay, I will do that graphically, that paradox. Huh? Okay, now tell me. Okay, so how much this object is? How much this object is? Is this less than 1? Because velocity is always less than c, is it? So this is less than 1. So what this should be then? dt prime is less than 1. Okay, so that is smaller than what you are observing, is it? Samajh aawa? So it means the moving clock slows down. Now let's integrate from t1, let's say a to b. Okay, so we can have t2 prime minus the time what we observe. So it's like this. 1 minus v square by c square. Clear? So this is actually the proper time in terms of the time what we are measuring, is it? So this is the famous formula of the time dilation, and we have arrived it without using the Lorentz transformation. Okay, we can use without Lorentz transform, we can arrive at what? Length contraction, because of this kind of relation. Okay, so because of this very objective. So we can arrive at the length contraction as well from this very invariance. Okay? Let's think this way. So you should have asked that question. I was expecting. Suppose I am having, let's say, one clock is moving with respect to the another clock, is it? And I am observing the moving clock slows down, is it? But for a moving clock, so the another clock is also moving, is it? Isn't it? Shall that clock show a slower time for a moving clock? Suppose one person is moving with respect to another person. Let's say person A moves with respect to person B, but for person B, A is also moving with respect to him, is it? With the same, although in the opposite direction, but in the same, at the same velocity, is it? So is it a reversible phenomena, a reversible effect? So it's a question for you people. Think over it. Tomorrow you have to answer it. Okay? So is it a reversible phenomena? Can the clock, which is where from we are measuring, okay, can it give the same kind of effect for a clock that's moving? So you got my point? Try to do it at your places. Okay? So this proper time, since this is a proper time, we will take this the time, this kind of parameter we will be taking in dynamics. Okay? In this proper time. Now, why it should be taken? Why it is different from the usual time? This proper time is actually an invariant quantity. It is an absolute quantity. For everybody, if for everybody there is a proper time, and it's an absolute quantity. Okay, let's check it how. So you are having this very relation, ds square is equal to c square dt square minus dx square minus dy square minus dz square, is it? So that is same as what? dt prime square minus dx prime square minus dy prime square minus dz prime square, is it? So since this is equal to 0 in our case, so what it gives me? So it gives me dt prime as ds divided by what? C, is it? So what is that equal to? That is simply equal to dt root of 1 minus v square by c square. You can take dt out here, is it? It will be c dt, but c I have divided here, so it will be like this thing. Clear? So what this dt prime is? It is the proper time. Is that true? So now what this object is? It is the length of the interval. Is it? Or it is an interval? That is an absolute quantity. What c is? What is that? Ratio of two absolute quantity is what? An absolute quantity. So that's why this proper time is an absolute quantity. We always write this proper time in terms of this length of the interval. Or in other words, the length of the interval always gives you the proper time. Okay? Obviously with the velocity c, you have to divide it with the velocity c, but the this interval is actually the proper time. Okay? Samashavan? Got it? Samashavan? Okay, I will give one point. Suppose if you are having a particle that's moving from, let's say, A to B, how do you define its velocity? Usually, forget about relativity. So you define it, if you know x of t, so you define it what? dx of t by dt, is it? So since in Newtonian mechanics, time is same everywhere, is it? But when you say in the relativity, time changes from one point to another point, is it? Because every point you can consider what? A clock attached to it, is it? And the moving clock slow down, is it? So what is the time you can choose here? So you need a quantity which is an invariant of the motion, is it? So which remains the same throughout the motion. Samajh aaya? Or which is an absolute quantity. What is that absolute quantity? It's actually the proper time. Or in other words, it's actually this very ds is the objective what we will be using. So, Samajh aaya? Everybody followed it? Clear?